Hey everyone, welcome to The Explainer. Look, if you've ever had to deal with cracked, leaking, or just totally failing concrete, you know how incredibly frustrating it can be. Today, we're diving into the ultimate guide to mastering concrete joint repairs using a highly specialized solution. Let's jump right in.
So let's start with a really foundational question. Why do expansion joints actually fail? We kind of tend to think of concrete as this static, immovable rock, but the reality? It's a living, breathing, moving system. It is constantly reacting to its environment. And the joints? Well, they're the flexible shock absorbers designed to protect the whole structure, yet they are almost always the very first thing to break down. Why is that? To figure out the failure, we just have to look at the physics for a second. As a quick refresher, building faces, concrete slabs, and pipelines constantly expand and contract due to daily and seasonal temperature variations. If you don't have a reliable, flexible shock absorber in those gaps, the concrete is inevitably going to crack under the sheer stress of that movement. And once it cracks, water gets in and your structural integrity is completely compromised. Okay, so here is our roadmap for today. Number 1, concrete under stress. Number 2, meet Maxjoint Elastic Express. Number 3, 11 key benefits. Number 4, preparing and mixing. And finally, number 5, application and curing.
Section 1. Concrete under stress, the core problem. Before we get to the solution, we really need to paint a picture of what happens when joints are left vulnerable. The source material highlights this wild example of a pole side up on the Gold Coast. It suffered from severe delamination and splitting, literally a complete structural failure. But why? Well, it usually comes down to a few major culprits: selecting the wrong product for a wet environment, applying it to a dry substrate when it desperately needs moisture, failing to use a bond breaker, or just generally poor application techniques that completely ignore the manufacturer's instructions. Which brings us to Section 2, Meet Maxjoint Elastic Express, the solution. To answer those severe failures, the documentation points us directly to this specific product. It's a superior elastomeric sealant specifically engineered for cracked concrete subject to serious movement. What's really fascinating here is the chemistry. Maxjoint Elastic Express is a two-component product. Component A is this liquid based on special synthetic resins, and Component B is a powder mortar packed with cements, additives, and aggregates. When you mix them together, you get a high bond strength elastomeric material. It comes in 10 kilogram or 2 kilogram kits, and just to put that into perspective for your coverage, a single 2 kilogram kit is going to fill up to 30 lineal meters of a standard 10 by 5 millimeter joint. All right, Section 3, 11 key benefits, the proof. Let's look at exactly why this stuff is trusted equally by commercial maintenance managers and serious DIYers. 15%. That is the in-service joint movement capability. Basically, as your building expands in the brutal summer heat and contracts in the winter freeze, this sealant stretches and compresses right along with it, all without breaking its bond. And then when it comes to capacity, 30 millimeters. That means this product can seal an active joint or a moving crack up to a maximum width of well over an inch. It allows you to tackle major structural gaps with a single, highly durable product. Now, these critical operational perks are honestly game changers. The big one? Excellent adhesion on damp surfaces. Actually, scratch that. It doesn't just adhere to damp surfaces. The surface absolutely must be damp before you apply it. This is completely counterintuitive if you're used to standard silicones that need bone-dry conditions. Add to that, zero bonding agent is required, it won't slump on your vertical walls, it's safe for permanent water immersion, think pipelines or swimming pools, and it's completely non-toxic and non-flammable. Moving right along to Section 4, preparing and mixing, the process. Let's walk through the exact methodology for the job site, step by step, to make sure you get professional results. First things first, the surface has to be solid and clean, and you must dampen the joint edge. Just make sure you remove any standing puddles of water. Second, pour your liquid component A and gradually add the powder component B. You're going to mix that using a low-speed drill, somewhere between 400 and 600 RPM, until it's totally lump-free, then let it rest for 2 minutes. And definitely keep an eye on the clock here. Your pot life is 30 to 60 minutes. You can remix it to keep it workable, but remember one absolutely critical rule. Which brings us to this strict warning pulled directly from the manufacturer's datasheet. Do not add cement, water, or aggregates to Maxjoint Elastic to achieve higher coverage. I know it might be super tempting to stretch the product on a massive job site by just adding a quick splash of water, but doing so fundamentally alters the chemical ratio. It completely compromises the integrity and elasticity of the seal. Just don't do it. And finally, Section 5,
application and curing the final steps.
Okay, so we've mixed the product flawlessly. Now it's time for the physical application. First up, use a polyethylene foam backing rod, like the Maxjoint rod, that is 25% wider than the joint itself. This prevents stress on the bottom of the sealant. Apply the mix with a trowel or a caulking gun, and listen, you absolutely must push against the bottom and the edges to squeeze out any internal air bubbles. Smooth it out immediately with some soapy water. And a super vital weather warning here. Never, ever apply it below 5 degrees Celsius or onto frozen or frosted surfaces.
Now, because this is the express version, the curing journey is incredibly fast. Check this out. After just 8 hours, it can already handle pedestrian traffic. At 24 hours, vehicular traffic. In 3 days, it's ready to be permanently immersed in water. And after a full 7 days, it is completely cured and ready to be painted or coated with other membranes. That is getting a site back to service fast.
There is a quick caveat to those seriously impressive speeds, though. Those fast curing times assume a standard temperature of around 20 degrees Celsius and about 50% relative humidity. If you're working out in an environment below 10 degrees or if the humidity is really high, those times are going to extend. You just have to work with your environment, not against it.
The bottom line here, concrete is always going to move, but joint failure, that's entirely optional. By understanding the physics of expansion, selecting a flexible elastomeric solution, and following those precise damp surface application rules, you are fully equipped to execute a permanent repair. So ask yourself, is your building actually prepared to weather the stress of constant structural movement? Thanks for joining me on this explainer. Keep learning, and I'll catch you next time.